Dr. Germino, you have been among the first to isolate the gene for coding for polycystin, and you have been most influential in recent years in translating these results of basic research to the bedside, actually to the benefit of patients. Do you have any important news about progress being made in the treatment and in the prevention of this disease?
One of the important outcomes of having identified the gene over a decade ago was that we could use this information immediately for a couple of things. One was to develop clinical tests, which are now in use, that can be used to establish a diagnosis in individuals where the clinical features are not yet adequate. And that's something that is now in practice. A very important second goal or second outcome from having identified the gene is that we can use this information to now make better tools for studying the gene's function and for developing preclinical tools for developing therapies. And one of the more exciting things I think I've seen in the last several years is the development of new models, mouse models that very, very closely can mimic the human condition. The diseases in these models develop as a consequence of mutations of the same genes that cause disease in humans. And we can now, by modifying the way these genes become mutated, we can actually reproduce the natural history of the disease. And this has revealed some surprises. We know, in fact, that previous models, although helpful, informative, and in fact been useful in giving us better insight into the pathobiology of PKD, they're limited in that the disease does not follow the same course. And so now we have models that we can use, in fact, to test preclinical therapies and try to use this information to walk that very narrow line between judging whether a therapy is safe versus the risks of the therapy are worse than the potential benefits of the therapy in individuals. And so I'm very hopeful now with these new models. We can test potential therapies, show what the subset which are hopefully most effective with the least amount of risk, and then use this as the basis for going forward with clinical trials over the next several years. I also think the studies in these models will not only be helpful in developing therapies in the short term or testing therapies in the short term, but they'll hopefully also allow us to understand the biology of the disease more precisely so that we can achieve our long-term goal of finding a cure. Because only through understanding the disease on a mechanistic level, on a molecular level, will we be able to find a lasting cure.